Welcome to Basic Electrical Engineering lecture series. This is a series of lecture videos for the first year engineering and electrical diploma students. In these videos, fundamentals of DC and AC circuits, network theorems, fundamentals of transformers, DC and AC machines, and renewable energy sources are the topics covered. Sufficient number of numericals are worked out in each session to make the concepts clear to the viewers. For a basic idea about the topics mentioned, please watch these videos from the very beginning itself. If you find the videos useful, please subscribe for the channel, like the video and press the bell icon for notification. Please try to wear a headphone and watch the video for better sound clarity. Thank you all. And now let's start with today's session. So in this session also, some examples are worked out in AC series circuits. Now the first example is a voltage of 220 volts at 50 Hertz is applied across a series circuit with R is equal to 10 ohm and L is equal to 50 millihenry. Find the impedance of the circuit, current through the circuit, power consumed by the circuit, power factor, voltage across the resistance and voltage across the inductor. Now the circuit is given here. It's an AC circuit. The RMS value of voltage is 220 volts. Frequency is given as 50 Hertz. The circuit has a resistor of 10 ohm and an inductor of value 10 millihenry. So the given information is V is equal to 220 volts, frequency 50 Hertz, R is equal to 10 ohm and L is equal to 50 millihenry. So the first part of the question is to find out the impedance of the circuit. So we have to find out the inductive reactance. Then we know the value of R, we can find out the impedance of the circuit. So inductive reactance XL is equal to omega L or 2 pi FL. So 2 pi into 50 millihenry, you will get it as 15.7 ohm. So the impedance of the circuit Z is equal to R plus J XL. So R is equal to 10 ohm, XL is equal to 15.7. So 10 plus J 15.7 is the impedance of the circuit in rectangular coordinates. We can convert it to polar coordinates. So magnitude of the impedance is square root of 10 square plus 15.7 square, that is 18.61. Then tan inverse 15.7 divided by 10, that is 57.5 degrees. So next part is to find the current through the circuit. Current is equal to voltage divided by impedance. Voltage is given as 220. Let's take it as the reference. So 220 angle 0 divided by impedance, that is 18.61 angle 57.5. So magnitude is 220 divided by 18.61. 220 divided by 18.61. Sorry. 220 divided by 18.61, that is 11.82. Angle 0 minus 57.5, that is minus 57.5 degrees. So magnitude of the current through the circuit is 11.82 ampere. It is lagging behind the reference by an angle of 57.5 degrees. Okay, the next part is to find the power consumed by the circuit. So power is equal to Vi cos phi. In AC circuits, the equation for power is Vi cos phi. So in this Vi is magnitude of the voltage, I is the magnitude of the current into cosine of the angle between V and phi. That is the power factor angle. So when we are using the equation power is equal to Vi cos phi, please note that V is magnitude of the voltage, I is the magnitude of current into cosine of the angle between these two quantities V and I. That is the power consumed by the circuit. So magnitude of the voltage is given as 220 volts. So in the data magnitude of the voltage is 220 volts. So 220 into magnitude of current we found out that is 11.82. So to find the magnitude of the current we have to take the magnitude from the polar version. So current is 11.82 angle minus 57.5. So 11.82 is the magnitude of the current passing through the circuit. So 220 into 11.82 into here angle is given, cosine of the angle between V and I. V is taken as the reference. I is at an angle of 57.5 degree, lagging behind the voltage. So the angle, magnitude of the angle between voltage and current is 57.5 degree. So voltage we are taking it as the reference. Current is lagging behind the voltage by an angle of 57.5 degrees. So the angle between voltage and current is 57.5. So 220 into 11.82 into cos 57.5, get it as 1397.19 watts. That is the power consumed by the circuit. Next is power factor. Power factor is cosine of the angle between voltage and current. So angle between voltage and current is 57.5 degrees. So cos 57.5 is the power factor, that is 0.5373. Then the last part of the question is voltage across the resistor and voltage across the inductor. Voltage across the resistor VR, that is, this is VR. And voltage across the inductor, let's take it as VL. VL is the voltage across the inductor. So VR can be found by multiplying I into R, and VL is I into XL. So VR is equal to I is 11.82 ampere into 10 ohm, that is 118.2 volts, that is the voltage across the resistor. VL is the voltage across the inductor, which is I into XL. I is 11.82. XL is the inductive reactance, that is we got it here, 15.7 ohm. So 11.82 into 15.7, 185.57 volts. So the phasor diagram, if you want, it is better to, let's take, this is I, here I is taken as the reference. This quantity is I into R. I into R is 118.2 volts in phase with I. This is I into XL. I into XL is VL. This is VL or I into XL. It is equal to 185.57. 185.57 volts. IR is 118.2 and I into XL is 185.57. So this is square root of 118.2 square plus 185.57 square. It is equal to, voltage is already, we know that is 220. You can solve it and check, counter check whether it is 220 volts. Here I have taken as reference, or you can draw like this also. V, this is I is equal to 11.82. This is I into R, that is 118.2. This is I into XL at an angle of 90 degree, leading the current. So this is the resultant voltage V, which is equal to 220. This is I, this is I into R, that is 118.2. This is I into XL, that is 185.57. This is the power factor angle phi, that is 57.5. 57.5 degrees. Either way we can draw it. The next question is, when a voltage of 220 volts at 50 Hertz is applied across a series circuit, a current of 10 angle minus 30 was drawn. Find the elements of the circuit. So it's given that the given circuit is a series circuit, and the applied voltage, RMS value applied voltage is 220 volts, frequency 50 Hertz. The current drawn by the circuit is 10 angle minus 30. We have to find the elements of the circuit. It's given that it is a series circuit. So we don't know the elements of the circuit. I'll just mark it as Z, impedance of the circuit. This is the voltage. Magnitude is 220 volts. Current is 10 angle minus 30. Which is 10 angle minus 30. Here we have to take the voltage as the reference, 220. No angle is given for that. So V is 220 angle 0. I is 10 angle minus 30. So impedance is equal to V by I. V, no angle is given for that. I am taking it as 0. That's the reference. V divided by I. I is 10 angle minus 30. It is given. So when we divide 220 angle 0 divided by 10 angle minus 30, it's equal to 220 by 10, it is 22. 0 minus 30 plus 30. So 22 angle 30 is the impedance of the circuit. So convert it into rectangular coordinates. 22 angle 30 in polar form, when it's converted to rectangular coordinates, it is 22 into cos 30, that is 19.05, plus j 22 into sin 30, that is 11. So when you convert 22 angle 30 into polar coordinates, you'll get into rectangular coordinates, you'll get 19.05 and 11. 19.05 plus J11 is the impedance in rectangular coordinates. So from this it is clear that real part is 19.5. So it is a resistor of value 19.05 ohm. So the imaginary part is an inductive reactance because it is plus J11. So it's an inductive reactance. That is XL is equal to 11 ohm. So XL is 11 ohm, frequency is Frequency is not given. 50 hertz. Frequency is given 50 hertz. So the value of the inductance is XL divided by 2 pi f, because XL is equal to omega L or 2 pi FL, omega L or 2 pi FL. So L value is XL divided by 2 pi f. We'll get it as 0.03501 or approximately 35 millihenries. So the series circuit has a resistance 19.05 ohm and an inductor of value 35 millihenry. So the phasor diagram of the circuit, I is given as 10 angle minus 30. It is given in the question itself. I is 10 angle minus 30. So I is equal to magnitude 10. This is lagging behind the voltage by an angle of 30 degrees. This is the voltage V is equal to 220 volt in the reference direction. I lagging behind V by an angle of 30 degrees. Now there are only two drops. One is IR. This is I into R. This is I into XL. So V square is equal to IR the whole square plus IXL the whole square. The phasor diagram is like this. I current lagging behind the voltage by an angle of 30 degree. IR is the voltage across the resistor. IXL is the voltage across the inductor. So V is equal to square root of IR square plus IXL square. So the elements of the circuits are a resistor of 19.05 ohm and an inductor of value 35 millihenry. Next is when a voltage of 100 volts at 50 hertz is applied across a series circuit, the current drawn is 8.66 plus J5 ampere. Find the elements of the circuit. This is similar to the previous one. Again, an impedance. It is given that it is a series circuit. So finally, whatever elements we are getting, those elements are to be connected in series. So the applied voltage is 100 volts, frequency 50 hertz. Current drawn is I is equal to 8.66 plus J5 ampere. So the current, it is given in rectangular coordinates. So let's convert it to polar coordinates. That is, magnitude is square root of 8.66 square plus 5 square. Square root of 8.66 square plus 5 square. It's equal to 10. Angle tan inverse 5 divided by 8.66. Tan inverse 5 divided by 8.66 equal to 30 degrees. So the current is 10 angle 30. So the impedance of the circuit is Z is V by I. V is 100 volts. I is equal to 10 angle 30. So 100 I am taking it as reference. So 100 angle 0 divided by 10 angle 30. So the resultant is 100 divided by 10, that is 10. 0 minus 30 is minus 30. 100 angle 0 divided by 10 angle 30. So divide the magnitude 100 by 10, it is 10. 0 minus 30 is minus 30. So 10 angle minus 30 is the impedance. So converting it back into rectangular form or converting to rectangular form, it is 10 into cos minus 30 plus j 10 into sine minus 30. So it is 8.66 minus j5. 10 into cos minus 30 plus j 10 into sine minus 30. Sine of minus 30 is minus sine 30. So the impedance is 8.66 minus j5. So it is in the form R minus jx. So it is a capacitive reactance R minus jxc. So the circuit has a resistor as well as a capacitor. So resistor value is 8.66 ohm. Capacitive reactance is 5 ohms. And capacitor value is 1 by 2 omega xc. Xc is equal to 1 by omega c, or c is equal to 1 by omega xc, or 1 by 2 pi f xc. So solving it, as you will get a point 0.0064 farad or 640 microfarad is the answer. So the circuit has got a resistor of 8.66 ohm and a capacitor of 640 microfarad. The supplied voltage is 100 volts. So the elements of the circuits are resistor value 8.66 ohm and a capacitor with value 640 microfarads. Next example is a series RL circuit consumes a power of 1397.19 farad. So it's given that it is a series RL circuit, resistor, inductor. So it consumes a power of 1397.19 watt at a power factor of 0.5373 when connected to a 220 volts 50 hertz supply. So RMS value of applied voltage is 220 volt, frequency 50 hertz. So power and power factor are given. So take the current is equal to I. This is R L. So power is consumed by, power can be found using two equations, Vi cos phi and I square R, because in this circuit there is only one resistor, or power is consumed only by resistors. Your inductor or capacitor do not consume or does not consume power. So power in this circuit can be found out using two equations, Vi cos phi or I square R. If we use Vi cos phi, then power consumed by the circuit is 1397.19. It's equal to 220 into, that is V, into I, value we do not know, into cos phi. Cos phi is given 0.5373. Power factor is given as 0.5373. So power consumed by the circuit 1397.17 is equal to 220 into I into 0.5373, from which we can find the value of I is equal to 11.82 ampere. Again, power consumed by the circuit is also I square R, I is known now. So 1397.17, that is power is equal to 11.82 square into R, from which R we can find out 10 ohm. Then impedance of the circuit is V by I. This will give you only the magnitude of the impedance. So V is 220 volts applied voltage. I is equal to 11 point. Magnitude of the current is 11.82 ampere. So magnitude of the impedance is 18.61 ohm. Now inductive reactance can be found out. R, XL, Z. So Z is equal to 18.61. R is equal to 10 ohm. So XL is equal to, this is a right angle triangle, XL is equal to square root of 18.61 square minus 10 square. That is 15.7 ohm. So therefore the value of inductance is XL divided by 2 pi f. XL is 15.7 divided by 2 pi into frequency is 50 hertz. We'll get it as 50 milliamp. So the series circuit, the elements of the circuits are a resistor of 10 ohm, and an inductor of 50 milliamp. Now the next example is an alternating voltage of 100 plus J20 volts is applied to a series circuit, and the circuit draws a current of 4 minus J3 ampere. Find the elements of the circuit and power consumed by the circuit. So the voltage is given as 100 plus J20. So when you convert it to polar form, voltage is 100 plus J20. When you convert it to polar form, it is 101.98 angle 11.31. Then current, it is given as 4 minus J3. Converting it to polar form, it is 4 minus J3 is square root of 4 square plus 3 square, that is 5 angle minus 36.86. Angle is tan inverse minus 3 by 4. So 100.98 angle 11.31. That is reference line. This is the voltage. Not 100, 101.98 at an angle of 11.31. Current is 5 ampere at an angle of minus 36.86 degrees. So voltage is 100 plus J20, that is converting it to polar form, it is 101.98 angle 11.31. Current is 4 minus J3, converting it to polar form, it is 5 angle minus 36.86. So impedance of the circuit is divide 101.98 angle 11.31 divided by 5 angle minus 36, will get it as 20.4 angle 48.17. So it is 13.61 plus J 15.2. So it's an RL circuit because here the sign is plus. So R is equal to 13.61. Inductive reactance is 15.2. So L is equal to XL divided by 2 pi f. XL is 15.2 divided by 2 pi into frequency is given as 60 Hertz. So L is equal to XL. XL is 15.2 divided by 2 pi into 60. That is 40.32 millihenry. So power consumed by the circuit can be found out by using the equation Vi cos phi or I square R. So I magnitude is given. I magnitude is 5. R is 13.661. So 5 square into 13.61, that is 340 watts. I is 5 ampere. That is I square R is 5 square into 13.61. Also power is Vi cos phi. Magnitude of the voltage into magnitude of current into cosine of the angle between voltage and current. So we can find the power using this equation also. That is Vi cos phi, which is V is 101.98, I is 5 ampere, and what is the angle between V and I? 36.86 plus 11.31. That is the angle between, this is voltage, this is current. Angle between voltage and voltage is leading the reference by 11.31. Here voltage is not in the reference line, because voltage equation is given 100 plus J10D, or it's 101.98 angle 11 point something. So current is lagging the reference by an angle of 36.86 degrees. So the voltage angle between voltage and current is 36.86 plus 11.31, that is 48.17. So power is Vi cos phi 101.98 into 5 into magnitude of the voltage into magnitude of current into cos 48.17. Again we'll get it as 340 watts. Next example, a series RLC circuit has 100 ohm resistance. It has an inductance of 1 Henry and a capacitance of 5 microfarad. A voltage of 100 volts at 60 Hertz is applied across it. Obtain the voltage across the resistance, inductance and capacitance. Okay, it's a series RLC circuit. R, L and C all are connected in series. R 100 ohm, L 1 Henry and capacitance 5 microfarad. So RMS value of applied voltage is 100 volt, frequency 60 Hertz. So R is 100 ohm. Inductive reactance XL is 2 pi FL. L is 1 Henry. So 2 pi F into 1. That is 377 ohms. Xc is equal to 1 by omega C, 1 by 2 pi Fc. So 1 by 2 pi F into 5 microfarad. 5 into 10 to the power of minus 6. So Xc is 10 to the power of 6 divided by 2 pi F into 5. That is 530.5 ohm. So the impedance of the circuit in this case is equal to R plus JXL minus JXC. Here an inductor as well as a capacitor, both are there in the circuit, in the series circuit. So the impedance is R plus the inductive reactance minus capacitive reactance, R plus JXL minus JXC. That is the net impedance of the circuit. So R is 100 ohm, inductive reactance XL plus J377, capacitive reactance is 530.5, so minus J530.5. So adding we will get 100 minus J 153.5. The net effect the circuit is capacitive. So 100 minus j 153.5 convert to polar form, square root of 100 square plus 153.5 square, that is 183.2, angle tan inverse minus 153.5 by 100, so angle is minus 56.91. So the net impedance is 183.2 angle minus 56.9. So current through the circuit is, voltage is given as 100 volt. So we have to take it as the reference. So 100 angle 0 divided by 183.2 angle minus 56.91. 100 by 183, that is 0.5458, angle 0 minus minus 56 plus 56.91. So I is leading, that is I is 0.54585 angle 56.91. So we have to find out the voltage across the resistor, voltage across the inductor, voltage across the capacitor. VR is equal to I into R. So 0.54585 into R is 100 ohm. That is 54.58 volts. Then VL is equal to I into XL. So this is I into R. VL is I into XL. I is 0.54585 into XL is inductive reactance is 377. So I into XL 0.54585 into 377, 205.78. VC is equal to I into XC, that is 0.54585 into 530.5, that is 289.57 volts. So voltage across the resistor is 54.58. Voltage across the inductor 205, this is 54.58. Voltage across the inductor 205.78, and this is voltage across the capacitor 289.57. So this is the phasor diagram. I is 0.54, is 0.5458 at an angle of leading, that is 56.991 degrees. This is I into R, I into R or VR. This is 54.58 from OA. OA is IR. I'll mark this as B and C. Then OA is I into R, that is 54.58 volts. Then AB is equal to VL or I into XL, 205.78. So AB is 205.78 volts. Then BC is equal to I into XC, BC or VC. AC is equal to I into XC, it is 289.57 volts. So BC is 289.57. Now we can counter check that this is V. V is equal to OA square plus AC square. V is equal to square root of OA square plus AC square. So square root of OA is 54.58 plus AC is BC minus AB. That is 289.57 minus 205.78. So 289.57 minus 205.78. whole square. So V is equal to square root of 54.58 square plus AC square, that is 289, which is 0.57, which is BC, minus AB is 205.78 square. You can counter check, you will get it as V will be equal to 100. So this answer will be 100 volts. So A is IR, resistive drop in phase with I. AB is I into XL, leading I by 90 degree, because inductor current lags the voltage or voltage leads the current. So VL should lead I. Then VC should lag I by 90 degrees. So from this direction 90 degree clockwise. So VC should be lagging behind I by 90 degrees. So this VC, which is 289.57 volts, is lagging behind I by an angle of 90 degrees. Next, a choke coil is connected in series with a resistance of 50 ohm and connected to a 220 volts 50 hertz supply. The voltage across the coil is 180 volts and voltage across the resistor is 120 volts. Find the resistance and inductance of the coil. So in the question it is given a resistance of 50 ohm is, a choke coil is connected in series with it. This is the choke coil. Choke coil has got an inductance as well as resistance. This resistance is the inherent resistance of the coil, not an additional resistance connected in series with it. The coil will be having a resistance, then that is represented by the small r. L is the inductance of the choke coil. And 50 is the resistor connected in series with the choke coil. So it is connected to a circuit where the RMS value of voltage is 220 volts. So it is given that voltage across the choke coil is 180 volts and voltage across the 50 ohm resistor is 120 volts. Now the phasor diagram will be like this. Let's take I as the reference, series circuit only. We'll take I as the reference. So I into R, voltage across the 50 ohm resistor, that is in phase with I. There is one more resistive drop in the circuit. One is I into this 50 ohm resistor. Another one is I into R. R is the resistance of the choke coil. So I into R as well as I into small r, both are in phase with I. So this is I into 50. Because value of R is 50. This is I into small r. R is the resistance of the choke coil, which we have to find out. Then I into XL. I into XL is the voltage across this part alone, across the inductor alone, or inductance of the choke coil alone. That is leading the current by an angle of 90 degree. So I into R, I into 50 ohm resistor, that voltage drop will be in phase with I. I into this small r, that will be in phase with I. I into XL, that will be leading I by 90 degrees. So this is the total voltage, which is given as 220 volt, which is the sum of three phases. I into R, which is the voltage across the 50 ohm resistor. I into small r, voltage across the resistance of the choke coil. I into XL, voltage across the inductance of the choke coil. This doesn't mean that these two are separate. R is the inherent resistance of the coil, choke coil. But the voltage drops, the phasor relationship is like this. Now it is given that voltage across the 50 ohm resistor is 120 volts. So this is 120. and voltage across the choke coil is 180. So this is 180. So voltage across the choke coil means IR plus JI into XL. So now we have to find out the value of R and L, resistance and inductance of the coil. Now from this phasor diagram, mark it as O, A, B, C. Now consider the triangle OBC. Now OC square is equal to OB square plus BC square. OC square is equal to OB square plus BC square. This is angle is 90 degrees. So we can write it as OC square. OB is equal to OA plus AB. The whole square plus BC square. So OC is given as 220 volts. So therefore OC square is 220 square. Then OA is given. OA is I into R, which is equal to 120. OA is 120. That is 120 plus AB. This ABC is a right angle triangle. So AB divided by AC is cos phi. AB divided by AC is cos phi. This angle is taken as phi. Therefore, AB is equal to AC cos phi. Or AB is equal to 180 into cos phi. So this AB is equal to 180 into cos phi plus BC. BC again, this right angle, this is a right angle triangle. BC divided by AC is sin phi, opposite side by hypotenuse. Therefore, BC is equal to AC sin phi or 180 sin phi. So this length BC is 180 sin phi. So we can write 220 square is equal to OA plus AB, 120 plus 180 cos phi, the whole square, plus BC 180 sin phi, the whole square. So expand it and add these two terms, 180 square cos square phi plus 180 square sin square phi, that will be 180 square. 180 square into cos square phi plus sin square phi. So this is equal to 1. So it is 180 square. So on the right hand side, you will get only unknown as cos phi. Cos phi is equal to 220 square minus 120 square minus 180 square. These two terms added. The whole divided by 2 into 120 into 180. So you'll get it as 0.03704, or phi is cos inverse of this, and it is 87.87 degrees. So this angle we found out. But current is equal to, current magnitude of the current we can find out. This voltage is 120 volts. This resistance value is 50 ohms. Therefore, current through the circuit is V by R. So I is equal to 120 divided by 50. That is 2.4 ampere. Again, using the relation, AB is equal to 180 cos phi, or IR is equal to 180 cos phi, and IXL is 180 sin phi. This length BC is 180 sin phi, or IXL is 180 sin phi. Therefore, we can find the value of R from this. We know I is 2.4. 180 into cos phi. Cos phi is 0.0370. So we can find the value of R. R is 180 cos phi divided by I is 2.78 ohm. XL is 180 sin phi divided by I is 75 ohm. L is equal to XL divided by 2 pi f. XL is 75 divided by H is 50 Hertz. So 75 divided by 2 pi into 50, that is 0.236 Henry. So that's all for today's session. Hope you liked the video. If you liked it, then kindly forward it to your friends and subscribe for the channel. Thanks for watching.